All right, we got the distributive property on our plate today. How is the formula for a perimeter of a rectangle an application of the distributive property? Good question. Wonder if we can figure that out. All right, so today we're going to start with an example. Sophie was buying supplies for school. She bought 4 notebooks that cost $3 each and 4 packages of pencils for $2 each. So write an expression showing the situation. All right, so this particular situation can be written just like this. 4 notebooks at $3 each, 4 times 3, plus another 4 packages of pencils that were $2 each. So I can do that. I want to know, can I write this expression if I just want to show that she bought 4 times the number of notebooks and pencils? Because really, she's doing 4 notebooks and 4 pencils. So could I write that just in a different way? And the answer to that is yeah, I can. I can write it just like this. I can say that, hey, 4 of the $3 and the $2 together. All right, and so how do I evaluate both? Well, let me evaluate both one at a time. If I evaluate this top one, I wrote it right here. 4 times 3 is 12. 4 times 2 is 8. Add those two things together, I get $20. If I evaluate the bottom one, if I add 3 plus 2 first, which is 5, and then times it by 4, I also get $20. So here to show you that these values are going to be exactly the same, however I write them, whether I write them this way or whether I write them this way. And so that introduces us to the distributive property. To multiply a sum or difference by a number, multiply each term inside the parentheses by the number outside. We'll say what? That basically tells you this. Look, when I have, this is the algebraic way to show you, A times the quantity B plus C, that's the same thing as A times B plus A times C, just like that. And here's some numbers to show you. 3 times the quantity 6 plus 1 is 3 times 6 plus 3 times 1, which is those there. Give me a second, I got to answer my phone. And the same is true as when you're subtracting. So if you distribute A times B, we can write that there, and then minus A times C. And there's a numerical example of that for you. So that's the distributive property. Let's go and get some examples on how to do that right now. So let's take a look. We're keep it nice and easy to start off with. We've given this, I have a 5 outside the parentheses, so I'm going to distribute it. I go 5 times 12 and 5 times 8, and I'm going to subtract those two things together, just like that. And so 5 times 12 gives us 60, 5 times 8 is 40, and I can subtract and get 20. But you may say, look, Mr. Ramos, why can't I just take 12 minus 8 and get 4, and then 4 times 5 gives me 20? So yeah, look, if I'm given a problem like that, that's probably what I would have done too, but I'm just showing you an example that does work this way, because what happens if I give you something like this? 4 times the quantity x plus 6, I can't take x and add 6 to it, right? Not if I don't know what x is. So I'm going to go ahead and distribute that, and I get 4 times x, which is 4x, and 4 times 6, which is 24. I'm going to leave those alone, and that would be the answer to the expression. Another example, I've got 6 times the quantity b minus 4. So I go 6 times b and 6 times 4, and I subtract those two in between. So that's 6b minus 24, and I leave it alone. I cannot combine these terms because they're not like terms. One has a variable, one does not. So this is a variable term, this is a constant. Cannot combine them. But wait, there's more. Yeah, you guessed it. All right, so I got negative 3 times the quantity x minus 5. One at a time, I go negative 3 times x, and then negative 3 times the 5 with the subtraction in between. So I can write it like this here, and I'll tell you, like in the future, I'm going to explain it in a slightly different way. But for now, since I want to be consistent, that's how I do that. And then this part here has an extra negative, so the opposite of a negative 15, change it to a positive 15. Okay. Next example, let's go another one where I go a little bit more difficult on you. 5 times the quantity, negative 2x plus 8y. All right. So one at a time, I just multiply those out, just like that. And my solution would be negative 10x plus 40y. Okay, this time both terms had a variable, different variables, so they're going to still end up as the solution. And I got one more with the fraction. You guys love fractions, so might as well throw one in there. 1/3 times the quantity x minus 9. I got 1/3 times x and 1/3 times 9, and subtract right in between those. So I get 1/3 x minus 3. All right, so those are the examples. And last but not least, how can we use a distributive property? Like, why do I ever need to know this information other than for your class? Well, look, if I've got this example, Jose wants to buy 5 DVDs for $19.95, and he wants to know what his total cost is going to be. Assume Jose doesn't have a phone with them or his calculator. How can he figure this out in his head pretty quickly? And so this is the type of math that I do in class without calculators. $19.95 is the same thing as $20 minus 5 cents. Okay, and so if I use the distributive property, I go, hey, 5 times 20, that's easy. That's $100. 5 times 5 cents, so that's 25 cents, right? And so I can figure out, 100 minus 25 cents is $99.75. So you can easily do 5 times $19.95 without a calculator, without a piece of paper. You can just kind of do these things in your head. All right, that's the notes for distributive property. Make sure you get those down. If I were you, I'd definitely get those 3 questions and your 3 sets in the summary so you don't have to worry about it later, and update your table of contents. All right, see you guys later.